Hello, welcome back to Curly Boy Theatre, everyone. I hope you all had a lovely lunch or other time zone appropriate break. Um, we have an exciting afternoon of more fun talks ahead of us. So, first up, we have ZQ Peng, sorry, who is a musician and composer who was born and raised in Hong Kong and came to Australia in 2012. Being a musician and an electrical engineer, Peng often incorporates improvisation and computer programming in his music. Peng has performed throughout Australia, including at the Melbourne International Jazz Festival and the Museum of Old and New Art. His most recent endeavor is using the open source software Abjad to create complexly notated music algorithmically, with every note generated and notated by the computer. Peng is also collaborating with the authors of Abjad to improve and maintain the software for interested composers. I'm looking very much forward to hearing this. CQ, over to you.
Thanks, Betsy. Yep. Hello. So today I'm going to talk about how to compose algorithmic music with Python and Abjad. Before I start, I would like to acknowledge the traditional owner of the land which I'm currently on. So the Boon people and also the Wurundjeri people of the Kulin Nation. I would like to acknowledge that they are the traditional owners of the land which I'm on, and I acknowledge the elders, past, present, and emerging. Um, yep, cool. So who am I? I'm ZQ, and yeah, I have two words in my first name. So I work as a DSP software engineer. And when I'm not working, I usually compose music and I perform music sometimes as well. These are my socials if you want to look for me online. All right. So in today's talk, I would first, give some sort of background information to algorithmic composition. Just a couple of examples, and then we'll look into a couple of existing softwares, including LilyPond, which is a music engraving software. Then we'll be looking at Abjad, just a little bit more in detail, including like how to extend Abjad as well. Then I will talk about how to structure your composition as a Python package, at least like the way that I do it, the way that I have been doing it. And yeah, that's it. All right. Cool. So I just thought the best way to introduce algorithmic composition is to give a couple of examples. So algorithmic composition is actually a thing that has been there for a pretty long time, much longer than computer was here. So even in Mozart's time back in the 18th century, I think, there was a pretty famous dice game which he invented, sort of. So the dice game go like this. So you can probably see the figures on the slides. The top picture, like we have kind of like a magic square looking like, squares. And then we have part of a segment of a music that Mozart has composed. So the performer or another composer, the procedure would be something like this. They would have to roll two dice and then use the sum to look up a measure number. So think of measure number to music as in an index to a Python list. So basically, using the sum to look up a measure number, and then they would repeat the process for however many times it is required, and finally concatenating all the segments together to form a new piece of music. So the general idea is kind of like to scramble the music by random chance. So you can see how there is a system and well-defined procedure to this composition or to this dice game. So, and it is very much doable by a computer, but obviously people didn't do it by computer. I imagine, I don't really know, but I imagine they were doing it by paper and pen. Yeah, so that was one example. And jumping forward a little bit in time, in the early 20th century, we have serialism, which is, a new school of thoughts in music composition. And one of the really prominent techniques in serialism is the 12-tone technique. And I'm really simplifying things here. So we have a tone row. So this is like kind of like the basic idea of the 12-tone technique, which is based on a tone row, which is a series of non-repetitive pitches. Apologies for those who don't read music, but like even so, you can probably see the, like 12 different notes on the slide there. So they are non-repetitive and, a series. And the composer can apply operations on a tone row to generate music materials. And the three main operations would be transposition, inversion, and retrograde. And the composers would apply these operations, any of these operations or combinations of these operations to generate music materials for their composition. So we'll look into transposition first. So we have the original tone row. I am labeling each pitch by a unique pitch class number, which is ranging from 0 to 11. So, because we're dealing with 12-tone technique. And in Western classical music, like, or in Western music in general, it is very much based on, an 12-tone thing, like in an octave. So that's why, 0 to 11. Yeah, with transposition, we're pretty much like preserving the contour of the original tone row, and then we're just like moving it up or down by however much we want. And in this case, we're kind of just like moving the original tone row up by a tone. So, just, by a little bit up. And the operation that we apply to the original tone row can actually be done by just one line of Python code. So you can see like, on my screen here, on my slides here, we have pitch plus 2, modulo 12 for pitch in original tone row. So that's, that's the Python code that we have to perform to transpose the tone row. So like, pretty simple. And it is very much doable by a computer. Of course, a lot of composers have been doing it by hand, which is fine as well. But, I just would like to point out, well, there are actually a lot of techniques in music composition that can be done by a computer algorithmically. All right, so next up we have inversion. So this time we are preserving the contour, but we are flipping it upside down. So again, this is very much doable by just one line of Python code, just a list comprehension kind of thing. And we have 5 minus pitch modulo 12. 5 is kind of like a magic number in here. Of course, like if you want to, change 5 into 6 or 7, like that is perfectly fine as well. It will just be, transpose like up or down. So like moving up or down. And then we have the inverted tone row below. So, that's how we generate the inverted tone row. All right, and next up we have retrograde. So this time we're preserving the contour by flipping it. So instead of like having it upside down, this time we're having it, so we're flipping it sideways. And again, just one line of Python code, and we are using the reverse method in Python to reverse the lists, and the rest, plus 2 is just to move it up by a whole tone basically. And then we have the reverse tone row. So you can see like all these techniques, although they were invented like in the early 20th century, but a lot of those like can actually be done by computer, like using today's technology, especially in Python. All right, so as I've mentioned, those were just a couple of examples of algorithmic composition. There are a lot of other techniques as well. So, there are some software which there are also some software which help composers to either compose music or to notate music. So with notation software, I'm just like listing a few here. So we have Sibelius, Finale, LilyPond, they're all notation software. They're really good at doing their job, which is to notate music. And we also have composition software, so OpenMusic or Bach, and they are again very good at doing, what they do. So for example, with Open Music, like the composer can use Open Music to generate music material kind of algorithmically, but to notate the actual music, like the composer would often have to resort to using other softwares. And kind of similarly for notation software as well, a lot of the software doesn't actually provide algorithmic composition capability to the composer. So they would have to resort to using, other software or even composing by hand first, like to get the idea of what they want to notate and then notate it using those software. So, that's why Abjad kind of becomes really handy because it kind of bridges the gap between the notation software and the composition software. So pretty much like everything can be done within Abjad. So both composition and notation. So to get a better understanding of where this Abjad sits like in this kind of software landscape, we would have to look at LilyPond first. So LilyPond is a music engraving program. So it is not like in terms of the interface, it is not too different from, for example, LaTeX. But the architecture is probably very different from what I know. So here's a block diagram. So it takes a plain text file, a .ly file, as the input, and then it can generate music notation in the form of a PDF file or other formats as well. I'm pretty sure like it can generate EPS file or PNG file as well, or JPEG. I can't really remember, but yeah. So like the LY file kind of looks like this. So you can see new voice C4 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 C4, and then we have 4 notes here. So that's kind of the idea of LilyPond. So just taking plain text, generating music notation. All right, so I thought I would, give you a really brief look at of what a LilyPond file would look like. So this is an example taken from the LilyPond's documentation. So again, like we have notes here. So notes, they are just like kind of like a circle, like filled with filled with black color, and those are musical notes. And yeah, so it corresponds to the code here. So we have D4, FIS, A, C, and we can also see the number, which kind of indicates the duration of each note. Then you can also see there are features in the score, like for example these like vertical lines, which are corresponds to the bar line here. And we also have some key signatures in here as well. So all those things like you would have to specify in the LilyPond file, and it can generate all these features in the score. And this is another example, so I'm not going to go into depth, but you can see even with the tie or slur, so this arc looking thing here, again you can specify in the LilyPond file, and that will generate the slur and the tie in the score. All right, and you can also do some a little bit more complicated rhythmic stuff in the music as well. So for example, you can use tuplet, which is to group 3 notes inside the space of 2. That's why 3 divided by 2 and so on. But this is just like a couple of examples of like what a LilyPond file would look like. All right, so those examples, they are pretty simple. There are not too many notes, not too complicated rhythmic stuff going on, and the file are relatively small, just a few lines. But you can probably imagine, like if I'm composing a really big piece, then the file would be pretty large. So this is kind of the next slide. So this file is just really large. So many lines, and apologies for the font, it's just really small. I'm trying to fit in, as much as possible on just one slide. And that was only about 1/10 of the file that was used to create this. So this is my composition. And this and this. So like not too much music here. I believe like there are only 21 bars of music in here. And like it takes a really large file, a really large .ly file to generate all these. So like if I'm kind of like engraving music, that's kind of fine. I know which note goes where exactly, and I know like, how to notate those things. All I have to do is just to, type the notes into the .ly file, and that will compile for me. Not much problem going on there. But when it comes to composing, like for example, like when I'm composing, I often have to go back and change things in my score. And if I'm working with such a big file, a big, .ly file, and I would have to look for, okay, where do I want to change my score? Which note do I have to change? And it's just like kind of, complicated when I'm dealing with the music note by note. So here is where Abjad comes in pretty handy. So Abjad is a Python package that helps composer build up complex pieces of music notation in iterative and incremental ways. And Abjad extends the Python language. So as a composer, I can use Abjad and I can utilize the power of the Python language and also other Python packages to assist my composition as well. And finally, Abjad wraps the LilyPond music notation software, so which is demonstrated by this diagram here. So we can create an instance of Abjad.voice, just a Python class. So Abjad.voice, and here we have kind of a music notation. It looks like LilyPond code, but it's not really. And Abjad can understand that, it will interpret that, and it can actually spit out LilyPond code when you call abjad .lilypond. So it will spit out LilyPond code, so you can call LilyPond to compile the code for you, and that will generate the music notation. And even better, Abjad actually has the capability to call LilyPond within itself. So all you have to do is to create an instance of abjad.voice, and then you can call abjad.show, and that will call LilyPond inside Abjad and generate the PDF as the output. So you don't even have to look at the LilyPond code at all. So pretty much like bypassing the process. All right. So to get, a little bit more taste of like how to use Abjad, I guess we'll start with a pretty simple example. So we'll start with just 4 notes. So on my slides here, we have, so of course, like if we want to use Abjad, we have to import Abjad. So I have a list of pitches, which is just 0, 1, 4, 6. So they are pitch class number. So, from 0 to 11. In this case, I can actually extend it to negative number and beyond 11 as well, but I'm not going to go into depth there. So what I'm doing here is to create an instance of abjad.duration. So 116, for those who understand music, that would be a 16th note. And for those of you who don't understand music, that's fine as well. So 116th is just basically a musical note with a pretty short duration. So 1/16 of a bar, I think. Then we can use abjad.leafmaker and provide it with the pitches and the durations, and that will generate the musical notes for us. So the output of this piece of code kind of looks like this, just like 4 notes. So, pretty simple, right? And one would almost suspect, well, like, why do I have to do it in Abjad? Like, when I can just like do it in LilyPond with probably like fewer lines of code. But here's the magic of Abjad. So you can utilize the Python programming language. For example, here I'm using some list operation. So just like extending my pitches list by using kind of like a list comprehension kind of thing. So I am extending my existing pitches using a for loop. And so like this create a list of length 16th, I think. And then I'm doing exactly the same thing. So, abjad.duration 116, and then using the leaf maker to make the leaves for us. So in the context of Abjad, leaves basically just means like, those musical notes. So the black dotted notes. All right, so the result kind of looks like this. And this is just me using a for loop in Python. So yeah, you can already see how I can extend this technique even a little bit more. So we can even retrograde the melody by reversing the list. So after extending the list, I am again extending the list and using reversed method. So here I am utilizing one of the 12 tone techniques, even though like this is not really 12 tone, but nothing stopped me from retrograding the melody. So the result kind of looks like this. So wow, like we can really see the benefit of using Abjad, because like if I have to do it in LilyPond, like it would probably take me like quite a while to figure out like how to retrograde and everything. All right. And we can also play around a bit with rhythm. So instead of just specifying like 1/16th, I am using a list of 3 different durations. So 2/16, 3/16, 4/16. And well, you might ask, well, okay, what happens now? Because like the length of the duration list and the length of the pitches list are different. So I believe like the pitches is of length 32, I think, and durations is only of length 3. So, wouldn't it not work? But it will actually still work. So Abjad kind of, it will just like cycle through the lists, and even though like the 2 lists they are of different length, but Abjad kind of, yeah, it will just like cycle through the list. So the result kind of looks like this. And now we are doing some like complicated rhythmic stuff. And for those of you who reads music, you probably notice that, oh, there's something wrong with the music. And in fact, like even for those of you who don't read music, that's fine as well. You can probably notice like in this bar line, and so like there is quite a bit of space between this bar line and this note over here. So there's something wrong with the music because I am playing just a little bit too much with the rhythm. So I would have to kind of fix this problem, and this is actually pretty easy to fix in Abjad. So I can, just specify the meter. So again, apologies, it's a musical time for those of you who don't read music. But yeah, in essence, I'm just like trying to demonstrate, all right, there are like a lot of useful methods and classes in Abjad. So for example, here I am using abjad.select.leaves group by measure. So you can see like, this is kind of like almost like really Pythonic kind of syntax. So yeah, and then I'm just using the meter class method rewrite meter, and that will rewrite the music for me according to this meter. So what I'm trying to do here is just to fix the duration problem which occurred in the previous slides. So yeah, then we have fixed the duration problem, and we have a proper piece of notated music. And I have been doing this step by step, and hopefully it's not too complicated, but you can already see how like Abjad provides a really convenient interface for composer to compose music step by step. And I can also add other stuff to the music as well. For example, I am going to add accents, which you will see just in a second what accent looks like. So here I'm using the previous example, and I am using a for loop. So you can see Abjad even provides some iterate functions for us to iterate over the music. So a lot of things are really object oriented. So even with musical notes, like I'm treating like every note as an object. So here I am iterating over the music, and please do not worry too much about the logical ties. It's just like more like an abjad term in there. But essentially, I am iterating over the music and adding accent for approximately every 3 notes, if you want, or every 3 ties. Alright, so I'm using the attach function to attach something to the music. So you can probably see like I'm adding accent. So by accent, I mean this thing, this triangular looking like thing to the music. So this is really iterative. So I am doing things like just step by step, and I'm like complicating the music. Just by a few lines of code every time. All right, so as you can see, the core abject library kind of provides many useful classes and methods, but they are not nearly enough to cover every algorithmic composition and techniques. So current extension includes abject-x NowArt, which is the quantization extension, and also the abject-x RMakers. So I'm not going to talk about RMakers because I don't really know much about it, but I'm going to talk about NowArt because that's the extension that I am currently maintaining. So with the NowArt package, it is the abject quantization extension. It is based on Paul Nauart's Q grids, the late Paul Nauart's Q grids, and it quantizes time-based events into music notation. So it looks something like this. So the composer would have to provide a list of durations and pitches to the Q event sequence, and that will be the input to the quantizer. Of course, it is very much configurable, and finally, it will generate music notation. All right, so to use the NowArt package, it would be something like this. So pretty much like similar to the block diagram, which I've just shown. So creating a Q event sequence, which is just, a sequence that the NowArt package can understand by providing a list of durations and pitches and calling the quantizer with the Q event sequence as the input. And that will do something like this. So you will be like, wow. And I really should have mentioned the durations are in millisecond. So yeah, one doesn't even have to understand that much about music notation, and they can, write something that is as complicated as this. So this is pretty useful, especially for, a top-down approach for composition. All right, and of course, we can utilize other Python package to assist our composition process as well. So as you can see, I'm using NumPy here. So I'm defining a function using NumPy to generate just a list of exponential distributed durations, and then I'm using NumPy again to select a just a list of random pitches for me, and finally using the quantizer to quantize the events for us. All right, so now we can create music in a rather abstract way. So just by specifying the music duration, so like the total duration of that piece, and then the average duration of each note with, in seconds, then, finally providing with a pitch set, so just a list of pitches, and we can have something like this. And we can also increase the density by decreasing the average duration of each note. And now we have something like this, even more complicated. And now we are torturing the musician. So, just by changing one number, we can have like so many different music generated for us. So yeah, I've shown you, how to use the abject and how to use the NowArt extension as well. But when it comes to composing a really large piece, we would want to structure our score somewhat. So we can actually do it in, in the Pythonic way as well. So we can structure it as a Python package, which is something that a lot of us are doing. So, a lot of us, meaning like, me and a few other composers who are using abject as well. So you can see like we have makefile, readme, just like a regular repository. And as you can see, we have info and also set up the py, which indicates, okay, we can actually pip install this if we want to. So I'm going into like the 40_7 directory, just like one of my composition in progress at the moment. And you can see there are a few Python modules. Again, I can install them if I want to. And the score will be built in the builds directory, etc., which is just like a few stray files, and segments, which is where I define, each segments of my music. And finally, we can actually PyTest our repository. So PyTesting my composition to see everything is working fine. And this is part of my definition.py inside segments a definition.py. So you can see, because I am treating this as a Python package, so I can actually import 47 from within, the segments directory, which is actually not part of the Python package. But because I am installing like other parts of the 47 as a package, so I can import 47 here. and I can use some of the modules from within the segments directory. So it is pretty useful that way to structure my composition. So yeah, that was more or less about all I can talk about in half an hour, I suppose. If you want to know more about Abjad, here is the Abjad website and the NAWAT quantizer documentation. There are also other music examples as well in these few links. So a lot of them, they have the link to the repository as well. So if you want, you can also have a look at their code. So yeah, that's it. Thank you very much for your time, and yeah, I hope you will have a great day after this.
Thank you so much, CQ, for that really, really lovely talk. I was saying in the chat that I don't have a whole lot of music experience, but I was able to follow that thanks to your lovely explanations, and it was really interesting. We don't have any time for questions, unfortunately. Ziki, do you have some time to step into the text chat in VenueList to answer? Because there's a couple of questions that were entered in.
Yeah, definitely. I will just jump into the text chat just in
Yeah,
a
the Curly
moment.
Boy Theater
Yep,
chat in
sure.
VenueList. I will copy the questions over there, everyone. Thank you so much again, ZQ, for a lovely talk. I know there were a lot of other musicy and not musicy people in the chat enjoying it as well. So thank you a lot.